Hello students, today we will see the concept of layering architecture. We will see the network architecture of the OSI reference model which utilizes the layering architecture. So now here we will first see the concept of layers in our real life. Here suppose we can consider an example wherein two friends wants to communicate through a postal mail by utilizing the services provided by the post office. So here we can see the entire task of communication has been divided in a layered architecture, or you can say entire task has been divided into three subtasks, and each task is carried out at a particular layer. For in this example, we can see here three layers are there. So at the higher layer, a sender user at the sender side writes the letter, put it into the envelope, write the source and destination address, and drop it into the mailbox. Then this letter is carried from the mailbox to the post office. From the post office, this task is done at the middle layer, and at the lower layer, the letter is delivered to the carrier by the post office. Now this letter is transported from source to destination through a transposition system, and then at the receiver side, at the lower layer, this letter is delivered from the carrier to the post office, and from the post office this letter is carried to the mailbox, and from mailbox to it is delivered to the intended recipient. So here we have seen this hierarchy of tasks over here. So the same concept is being utilized by the OSI reference model. So we can see what are the advantages of the layering architecture, why OSI uses the layering architecture. So first advantage is layering simplifies design. It also simplifies the implementation of the network model, and it helps in the testing of the model. Second advantage is at each layer different protocols are being implemented. Protocols can be defined as a set of rules that governs the data communication. So means the protocols can be assigned separately from those in the other layers, and protocols takes the services of the layers which is residing below it. The fourth example of using the layering architecture in network models are it provides the flexibility for modifying and evolving protocols and services. Now, if we talk about the non-layered architecture, so they are very costly. Uh, they are inflexible for any modification or evolving protocols and services at the later stage, and they are obsolete nowadays, so they are not being used. So these are the two popular network models in computer networks. First one is the open system interconnection OSI model. Second is the TCP/IP protocol suite or the network model. So here we'll discuss OSI model in details. So now coming to the OSI model. So this particular model was proposed by the International Standard Organization, which was established in 1947. This organization is a multinational body which is dedicated to worldwide agreement on international standards. And this open system interconnection model was introduced in late 1970s, and as per the OSI model network architecture, it divides it into 7 different layers. So what are those layers? We'll see now. So these are the layer of the OSI model. We can see there are total 7 layers. The lowest layer is physical layer, and the upper layer, highest layer, is the application layer. Now we can see the bottom 3 layers, that is physical layer, data link layer, and network layer, are known as network supported layers. Whereas upper 3 layers, that is session layer, presentation layer, and application layer, are known as user supported layers. So if we talk about the lower 3 layers, they are known as network supported layer because they deals with the physical aspects of moving data from one device to another, such as electrical specifications, physical connections, physical addressing, and transport reliability. Whereas the upper 3 layers, including application, presentation, and session layer, these layer allows interoperability among unrelated systems. That's why they are known as user supported layers. Now in between we can see the transport layer. So this layer acts as a link between two subgroups and ensures the data received from lower layers is in the form to be used by the upper layers. So here the upper 3 layers are implemented in softwares, whereas the lower layers are implemented in hardware as well as in the software. If you talk about the physical layer, this is completely implemented in hardware. So now you can see over here, this is the user supported layer and this the link between two subgroups. Now coming to means we can see over here how interaction happens between different layers of the OSI model. Here we can see in the figure device A and device B. They are connected through two intermediate nodes in between. Device A wants to send the message to device B. So how the flow of data through different layers of the OSI model will happen for successful communication. We can see over here. So in this diagram you can see at device A and device B all 7 layers are implemented, whereas at the intermediate nodes 3 layers are implemented. So we can see here the application layer takes the services from the presentation layer takes the services from session layer, and and so on. Similarly, in the machine, you can say within a single machine, each layer, if we consider device A, so within a single machine means in this device A, all 7 layers are implemented. So here each layer calls upon the services of layer just below it. Means layer 7 will calls upon services from layer 6, layer 6 will calls upon services from layer 5, and so on. Whereas in between the machines, like for example device A and intermediate node here. So in this layer n at device A, layer n at device A, for example, if we consider network layer at device A, communicates with the network layer of the intermediate node. Means layer n on one machine communicates with the layer n on another machine. Similarly, data link layer on device A communicates with the data link layer on intermediate nodes. We can see within a machine, in between two layers, we are seeing the interface. So this interface defines the information and services a layer must provide for layer above it. So now this is the entire process through which data will be sent uh, from one device to another device. So now here we can see these 7 layers. So here one more thing we can discuss. You can see between the device this application layer. This is 7th layer at device A and application layer at device B. They are communicating through peer-to-peer protocols. So these protocols are the set of rules that governs the data communication. So now we can see how exchange of information in OSI model is done. You can see the two things over here, that is the sender and on the right side a receiver. So here we can see this is you can think it of this is the overall view of OSI layers. So here D7 is the data units at layer 7 and H7 is the header at layer 7. So here sender user at the sender side send a message which is received by the application layer. So we call it as a D7. It's data at 7 layer. So now application layer will add the header information at this layer that will be known as H7, that is header at layer 7. So the process starts at layer 7, that is application layer, then moves from layer to layer in descending and sequential order. At each layer, header is added. We can see at each layer as we are moving from upper layer to lower layer, header or the trailers are added at each layer except the physical layer. And when we move from lower to upper layer, the headers or trailers are removed and the original data is forwarded to next layer and finally gets delivered to the receiver side. So here what is the header information that is being added at each layer? So header basically it is a unit of information which includes some control information such as source address, destination address, which guides the whole data packet to its correct destinations. Okay, so here we can see the trailers. Trailers commonly are added at layer 2, that is the data link layer. So what this trailer contains, it also includes the control information to ensure that the frames are received undamaged. Okay, so here we have seen the exchange of information in OSI model. Here one more thing we can discuss, like whenever data comes down and at the physical layer, it will be in the form of bits, and these bits will be converted in form of signal and it will be transported through a transmission medium. Okay, to the other side. Now here we will try to solve a question. The question is, in the layer hierarchy, as the data packets moves from the upper layer to the lower layer, headers are: option A is removed, B is rearranged, C is added, D is modified. So this is a very simple question. As we have already discussed, whenever we move from upper layer, means data move from upper layer to the lower